But let me choose another one like this, and then we'll look at more difficult situations. Let's say 60. Y squared plus 10y minus 26 equals 0. Okay. I'm asked to use completing the square. Okay. First step, I have to identify what? The middle coefficient, which is? I have to divide 10 by 2. What do I get? I have to square 5. What do I get? Good. This is the number I have to add to both sides. First, not to get confused, let's move 26 to the other side and then add 25 at the same time if you want. Y squared plus 10y plus 25 equals 26 plus 25. I moved negative 26 to the other side, and I also added 25. Remember, 25 has to be added to both sides. Otherwise, we change the balance. Good. Now, the left-hand side, I know it's a perfect square. I made it happen. And this is 51. What do I have on the left-hand side? Yes, indeed. And now, I didn't solve. I have to use something else, and the method is taking square roots. And this is y plus 5 equals, what do I have to write on the right-hand side? Good. Plus or minus is equal to 51, so negative 5, remember, please do not put it between plus or minus. Plus or minus have to stay in front of the square root of 51. So this is how we present the solution. We don't have to separate it because we cannot simplify it, so it can stay like this. Now let's look at the next level. The next level will be 44. 44 is more difficult, slightly more difficult, and you'll tell me why in a second. So x squared minus 7x minus 1 equals 0. Why do you think I claim that this is slightly more difficult versus this one and versus the previous one? Why? Because the middle coefficient is not divisible by 2. Exactly. That's the problem. So what is the middle coefficient then? Negative 7. I divide negative 7 by 2. Negative 7 halves. I square negative 7 halves. When I square a fraction, I square the top and I square the bottom. What do I get? 49 over 4. This is the number I have to add to both sides. Let's move negative 1 or 1 if you want first, together with adding 49 over 4 to both sides. So x squared minus 7x plus 49 over 4 equals 1 plus 49 over 4. Notice that 49 over 4 is present on both sides. Yes, Becky? Yes. This one? I do the same thing when I want to kick it. And that's it. It's nobody's fault but mine. Why would I kick it? My pleasure. Okay, so now I made the left-hand side a perfect square. By choosing the appropriate number here, I made it happen. And what is it? Exactly what I squared to get this. Indeed. X minus 7/2 indeed. And then the right-hand side, I have the least common denominator, which is 4. And I have to change 1 into 4 over 4. So then I have 53. After all this effort, I have to use another method now. So I take the square root. I expect 2 solutions. So then x minus 7/2 must be plus or minus the square root of 53 over 2. Therefore, x equals 7/2 plus or minus the square root of 53 over 2. Yes, when the middle coefficient is not divisible by 2, the calculations are a little bit more involving. Yes, Jackie?
Why is it not 48?
Uh-oh. Did I do something?
No, you probably did it right.
No, I'll rather go back and check. So the middle coefficient is -7. Then I have to divide it by 2. So when I square this, I square the top.
Yeah.
And I square the bottom.
Yeah, but when you put it into the equation, there's like the -1 already. Do you not like factor that in?
You mean here?
Yeah.
Because remember, the first term squared minus 2 times the first times the second plus the second term squared. If the middle term is negative, I have to have negative.
Oh, I see. Okay, I was confused about the 1. So you moved it over to
Yes.
Okay.
Yes. Because if I leave it here on this side, someone may be tempted to add it to 49 over 4
That's what I was
here. And no, I have to have it on the other side, like we did here. Yes. Is everything else okay? Okay, perfect. Now, there is one more level, and that's it. Let's say 65. This is the last level of difficulty. I claim that this is different than everything else we've done so far with completing the square. This was the first problem. This was the second problem. This was the third problem. And this is the fourth problem. What is different?
6 isn't the square.
Say it again?
6 isn't the square.
Nope.
The leading coefficient.
Yes, that is the problem. So here's a note. The leading coefficient must be 1 when solving by completing the square. Note, the leading coefficient must be 1 when solving by complete the square. It's a must. No problem. How do I get that equation to have a leading coefficient of 1? Absolutely. So then I have x squared minus 1/2 x plus 3 equals 0. When I divide, I must divide each and every term. When I divide 2x squared by 2, I get x squared. When I divide -1 by 2, I get -1/2. When I divide 6 by 2, I get 3. When I divide 0 by 2, I get 0. Are you with me? Now the procedure is exactly the same. What is the middle coefficient? -1/2 is the middle coefficient. It's like -50 cents. I divide -50 cents by 2. What do I get? Right, 1 over 4. And now I have to square -1/4. When I square -1/4, I get, remember I have to square the top and I have to square the bottom. When I square a fraction, I square the top, I square the bottom. 1 over 16. This is the number I have to add to both sides. And in the process, I must move 3 to the other side not to get confused. So x squared minus 1/2 x plus 1 over 16 equals negative 3 plus 1 over 16. So we did two things in one step. We moved 3 from one side to the other. It changed its signs. It changed its sign. And of course, I have to have 1 over 16 on both sides. Now the left-hand side is easy because I made it a perfect square. I made it into a perfect square. What perfect square? Say it again. Yes, indeed. X minus 1/4 squared. Perfect. The right-hand side has to have the least common denominator of 16. So the top, since it's over 1, has to get a 16. Negative 3 times 16 is negative 48 plus 1, negative 47. Are we okay? Everyone?
Where did you get the fractions?
The middle coefficient is negative 1/2. The next step is I have to divide it by 2. So when I divide negative 1/2 by 2, I get negative 1/4. I can show you on the side. Here's how we do it.
No, I got it.
Okay. And then I had to square this to get 1 over 16. And then I add 1 over 16 to both sides, and in the process I move this to the other side. Good. Are we okay so far? Okay, we complete the square. Now what? Right. We can finish it up with the square root, complete the square root alone. So then I have x minus 1/4 equals plus or minus. The square root of 47, I should write I, but we don't like to write anything after a root. So I'm going to put I in front. And divide by the square root of 16, which is 4. It's not a mistake to write the square root of 47 I. But we like not to write anything after a square root or a root in general. So then I only have to move 1/4, and I will not be able to simplify, so I will leave it alone. It's a complex number. It is what it is. So coming back to, where was I? Here? No. Here. Yes, here. So coming back here, we need more examples. Of course, we're going to review this. So I will consider this done. So this is the last method. Very useful, very useful, very useful. This, not here. Okay, so let's look at the quadratic formula. And this is in 11.2. Quadratic formula. We cannot apply the quadratic formula before the equation is set equal to 0. So this is our first step. So ax squared plus bx and plus c has to be set equal to 0 in the standard form. This is a must. Then I will have to identify a, b, and c. If one of those, b and c, not a of course, but if b or c are 0, I will, and I'm not forced to use the quadratic formula, I will not use the quadratic formula. There are other methods that are much easier. So if both b and c are present, I will use the quadratic formula. If b is 0 or c is 0, I will not use the quadratic formula if I have a choice. Okay. After I identify the coefficients, remember they are taken with a sign in front. make sure that this number is positive. If it's not positive, then multiply both sides by -1. Do not apply the quadratic formula if you have a negative leading coefficient. It is easier not to. Just multiply both sides by -1 first. So 2 conditions so far. I have to have 0 because otherwise I will not correctly identify A, B, and C if I have C on the other side or BX on the other side. So I have to have 0 in order to be able to identify correctly A, B, and C. And the numbers are taken with the signs in front. Also, I make sure that the leading coefficient is positive because it's easier to apply the quadratic formula when the leading coefficient is positive. Okay, then having done all those steps, performed all those steps, then I have the quadratic formula that we should remember. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. So try to remember this. I don't like to tell you to memorize stuff, but this is extremely useful. Negative b plus or minus, find the tune. Negative b plus or minus the square root of b squared minus 4ac over 2a. This quantity, just this quantity under the square root, is extremely important. I will talk about it in this chapter. It's called discriminant. Only b squared minus 4ac, not with the square root on top of it. We'll get back to it. Okay, so let's apply. I didn't forget we had left an equation hanging, right? The one with b cubed plus 1. Now we can solve it, but let me pick another couple of problems first, and then we'll go back to that one. Let's say 14 on page 669. 1/6 x squared plus x plus 1/3 equals 0. Again, we're not afraid of this. Why? Because we can easily make it human. Please make it human. How do I make this human? That's it. So how do I rewrite the equation?
X squared plus x
Equals 0 times 6, which is 0. Good. Is this equation in standard form? Yes. Can anyone identify A, B, and C that will be used and carefully plugged in here? Remember, this must be a positive number. You can never start under the square root with a negative symbol, please. The final simplified form of this could be negative, but you cannot start right with this by writing -9 or -81 or -16, correct? Because whatever you have b, you square it. And so this quantity will always be positive. Okay? Good. So can anyone identify A, B, and C for us? 1, 2. So now let's write the quadratic formula. Negative b plus or minus the square root of b squared. This number must be positive. The first thing I write under the square root. And then minus 4 times 1 times c, times a times c, divided by 2a. 2. Now carefully perform the operations under the square root. Remember, we cannot simplify this. From chapter 10. You cannot break the radical and say, oh, it's a square root of 36 minus this. No, you cannot do that. You have to perform the calculations under the radical. So then x equals -6 plus or minus. 4 times 1 times 2 is 8. 36 minus 8 would be 28, right? Divided by 2. The square root of 28, we learned in chapter 10. What do I do with the square root of 28? Very good. So then x is -6 plus or minus the square root of 4 which is 2, times the square root of 7 divided by 2. Remember, you cannot simplify. There are two ways, at least let's do one of them. You cannot simplify this with this, please do not do it. You cannot simplify this with this, please do not do it, because these are not factors, they're terms. So then x equals, you can do this, however. Split it into two fractions. I'm allowed to do this because the denominator is one term, so I can split into two fractions. Now I can simplify. Negative 6 divided by 2 is negative 3. And then I can simplify this 2 because it's a factor with this 2 because it's a factor, and I will write plus or minus the square root of 7. This I'm allowed. There is another option. I can factor out 2 from the numerator. 2, what is left in parentheses? 2 times what is negative 6, and I have to put it here.
3.
And then plus or minus. 2 times what is 2 the square root of 7? Exactly. And now I can simplify. And I get the same thing. So I'm allowed to simplify only factors. And now I think we are ready to go back to that problem. So we can finish it. Here it was. B squared minus b plus 1 equals 0. I said we have to wait till chapter 11 because we did not know the quadratic formula. So let's solve that. So b squared minus b plus 1 equals 0. Let's identify a, b, and c. How much is a? How much is b? How much is c? Good. So then b will be. Careful not to be confused. So this is a different b. It's not that b. Negative b plus or minus b squared, this b. B squared, I have to start with a positive number. B squared, 1 minus 4 times a, which is 1, times c, which is 1, divided by 2 times a, which is 2. So what do I have under the square root? I have 1 minus 4. How much is 1 minus 4? Right, so then the answer is 1 plus or minus the square root of negative 3 divided by 2. But I know how to replace the square root of negative 3 or what to replace it by. So then b equals 1 plus or minus I the square root of 3 divided by 2. Again, the square root of negative 3 is the square root of negative 1 times the square root of 3, and this is I. So we have the solutions to that. Any questions for me so far? Would you like to choose another problem from quadratic formula from page 669, 1 through 22? (669) 1 through 22. If not, I would like to look at a word problem or two. Yes, Becky? 19, very good. Let's look at 19. X squared plus 5x equals negative 2. I'm checking. X squared plus 5x equals negative 2. Correct. We're specifically told to use the quadratic formula. What is the very first step always? Yes, it's not in standard form yet. Very good. Very good. So then I have x squared plus 5x plus 2 equals 0. I have to identify a, b, and c. You don't have to write them on the side if you don't want to. I'm fine with that. But be careful how you plug everything in. So this is 1, this is 5, and this is 2. Negative b, plus or minus. Yes, minus 4 times 1 times 2 over 2a. So then x equals negative 5 plus or minus. 4 times 2 is 8. 25 minus 8 is 17. The square root of 17 divided by 2, and no one can further simplify this. Can I look at a word problem now? Maybe it's better if we talk about the discriminant, and then we look at word problems. Any questions for me? Okay, so let's look at this b squared minus 4ac, and you will see how important this is in this chapter a little bit later. Is this a real number? A and b and c are real numbers. If I square, multiply, subtract real numbers, what do I get? A real number. Good. So what are the options for a real number? When I say I have a real number, what are the possible options? What could I possibly have? I didn't mean the equal symbol. Sorry. On the inequalities. I don't know why I put that. No reason. So positive, 0, or negative. Good. Now I'm coming back to the quadratic formula for a moment. I'm going to write it again here. And I'm going to ask you what happens if this quantity, which is our discriminant, is positive. So if this quantity is a positive number, how many solutions will I find? Just imagine that we have 4. So how many solutions will I get?
2.
What type of solutions? If this is a positive number and I take the square root from 4, what type of solutions? Definitely 2. But what kind of numbers will they be? Because we know 2 types. We know real and imaginary. Will they be real? Will they be imaginary? Real, because I have a positive number here, right? So I will have 2 real, distinct, in other words, not the same, real solutions. 2 real, distinct solutions. Perfect. Now let's say that this whole thing is 0. How many solutions and what type? Becky? 1. However, still 2, but the same. 1 real solution. We will say 1, but we know it's still 2. It's quadratic, but the same solution. 1 real solution. Perfect. Now let's see what happens when the discriminant is negative. So in here, I have the square root of a negative number. How many solutions and what type? And we encountered all these situations here. 2, however, imaginary solutions. And you will see when we get to graphing a quadratic function how important this idea is. Okay, so let's look at a couple of examples of this and then a word problem. On page 669, I'm looking at problems 41 through 50. Please choose. Which one? 44 it is. 44. we have 9x squared plus 1 equals 6x. Let's read the question. Use the discriminant. In other words, you have to find it to determine the number and types of solutions of each equation. What would be my first step? What do I have to do first?
Subtract 6x.
Thank you. I have to subtract 6x, and not just that I have to subtract it and put it in the correct order. 9x squared minus 6x plus 1 equals 0. Excellent. Now I will have to calculate b squared minus 4ac. Can anyone give us b squared? Excellent. Minus 4 times a times c. What is the answer?
36.
Yes. And the answer for the discriminant? Right. What do we conclude about this equation? How many solutions does it have? And what type? One real solution. Uh, 50. You will see when we get to graphing these equations how important this concept is. 5 minus 4x plus 12x squared equals 0. Of course, they will give us these equations as twisted as possible because we need to put them in descending order. Otherwise, we can't identify A, B, and C and determine the discriminant correctly. So, of course, this is what? That's why I insisted on all polynomials to be presented in descending order so you can identify what to do or find out from the descending order, greatest common factor, and so on and so forth. Negative leading coefficient. So what do I have to do now first? Yes, that is my first step. Then I calculate b squared minus 4ac. Can anyone give us b squared? And you cannot give me a negative number. Be careful with that. 16, right? Minus 4 times 12 times 5. Since 4 times 5 is 20, 20 times 120 times 12 will be 240. I don't have to calculate. I already know the answer. Is it positive, negative, or 0? Negative. That's all I care about. What do I conclude about this equation? Two imaginary solutions. Now, one more remark, and then I will choose a problem. Okay, I want to go back. I want to go back to a solution like this one. So, see, this solutions for this equation are 1/2 plus or minus I the square root of 3 over 2. So, when the coefficients of this polynomial are real, that's what you will see most of the time. You're not going to get complex solutions. There are courses that deal with complex numbers only. So you're not going to get complex coefficients. The solutions will always be two complex conjugates. So if I have the solution a plus bi, I will have the solution a minus bi. Look, 1/2 plus I the square root of 3 over 2, and the other solution is 1/2 minus I the square root of 3 over 2. So complex solutions come in pairs. This is the complex solution and its complex conjugate. Okay, we're ready for word problems. On page 670, I'm going to just list a couple of things and you choose. I'll let you choose. Something about triangle, a triangle. Something about the hypotenuse of an isosceles right triangle. A holding pen for cattle. A rectangle is such and such. Any preference?
Triangle.
Okay, do I choose the triangle?
52.
52, excellent. 52 on 670. Is this baseball?
Sidewalk.
Okay, very good. The sidewalk. I'm thinking of baseball. What's the score? Is it 3-1 tonight? 3-2? I'm watching because they beat my team, so I'm hoping. Just kidding. Okay, 52. Given the diagram below, approximate the nearest foot to the nearest foot. How many feet of walking distance a person saves by cutting across the lawn instead of walking on the sidewalk? So and we are given, this is x, this is x plus 10, they say, and this is 40 feet. So the person can do this, or the person can do this to go from point A to point B. So he can go to the right and north, to east and north, or it can cut across the lawn, go directly to B. So we're asked to, given the diagram you see, approximate to the nearest foot. How many feet of walking distance a person saves by cutting across the lawn instead of walking on the sidewalk? So in other words, in order to compare, I know that this is 40, but I don't know how much this is. Once I find this distance, then I will say, oh. So it doesn't say, but it's not clear from the picture, but I will have to assume that this is a right triangle. Good. Any suggestions? Good. I'm ready.
A squared.
There is no A.
No.
X squared plus x plus 10 squared. 40 squared.
Excellent. So this is the equation that we have to solve. Now we know 4 methods. And no, you cannot take the square root from both sides because we cannot take the square root from a sum. So it requires work. So the left-hand side is x squared plus. We know a special product that we've been discussing since August. And we know how to square x plus 10. How many terms will I have to write? Exactly. First term squared. Plus 2 times the first times the second. And plus, right. When I square 4, I get 16. So 40, 1600. Minus 1600 equals 0. Good. Now I have to combine like terms. And I get 2x squared plus 20x. And then minus 1500 equals 0. Remember, factor, simplify, factor, simplify. I can't factor, but I definitely can simplify, and I will. By what? By 2. So then I have x squared plus 10x minus 750 equals 0. Yes, Becky? I have 4 methods. Which ones I will not even consider? Nothing else but the quadratic formula. I will not even think of spending my time on factoring. Numbers are too big, even if it's factorable. Once it tells me approximate to the nearest foot, obviously it's not factorable. I will not take square roots because it's not completed. The square is not completed. And I will never complete the square. Okay? So all I have to do is identify them and put them in the quadratic formula. So x equals negative b plus or minus the square root of 100 minus 4 times 1 times negative 750 divided by 2. I want to show this with a graphing calculator. Where is my calculator? Here it is. Now, when you put this in the graphing calculator, I recommend put it in one step, but you have to be very careful with parentheses. So let me come back here for a second. We need parentheses here for the top, and we need parentheses here. Although some of your calculators may be more sophisticated than I know, which is fine, but be very careful with parentheses. So the left parenthesis, when we start with the negative, you have to use the negative symbol right here, not the operational symbol. Negative 10 plus the square root. I don't trust this, you know that already. Put in parentheses, 100. I know that minus 4 times minus 750 will be positive, so I'm going to directly put positive. 4 times 750. Close the parenthesis for under the square root. Go outside, close the parenthesis again, and divide everything by 2. And press enter. I recall this whole operation with second and entry. Second and entry. And I go back and I override plus. I will put minus over plus. Minus for the other solution. And I get negative 32.83. These are the two solutions. And you can say not really, and I will have to agree. So x equals 22.8. Since they are asking us to the nearest foot, I'm going to say 23. And that's feet. And x equals negative 32.8 feet, and I'm going to cross it out. These are the two solutions. The second one cannot be accepted because it's a negative distance. I go back to my figure. So between A and B, the person is going 40 feet. And this is 23. Now I know this is 23 feet. And I know that this is 23 plus 10, which is 33 feet. So walking on the sidewalk gives us 23 plus 33. 23 plus 33, which is 56 feet. But the person cutting across the lawn will only walk for 40 feet. How much less is that from 56? So he is, yes, 16 feet less to cut on the lawn, cut across the lawn. We could have not solved this equation earlier because we did not know the quadratic formula. Okay, I have 8:12. Any questions? So let me just in 1 minute just tell you what's happening next. So 11.1 and 11.2 are done. What is left? 11.3, which deals with solving. We had a situation like that with substitution, solving equations still. 11.4, which is solving quadratic inequalities. And the last two deal with graphs. 11.5 and 11.6 are graphs of quadratic functions. So these two, the equations and the inequalities, I'm hoping to be